Today's group is about 30-ish people, it seems, remote plus local combined. All right, welcome to the GROW session at IETF 115 in London. If you're not supposed to be in London, please consult an adult. Thank you so much for attending this session. The GROW working group concerns themselves with operations of the global internet routing system. And these days, we also spend a lot of time on BMP, the BGP monitoring protocol. Today's session will be mostly split between focus on BMP and a novel proposal about describing BGP communities in a JSON format. Chris is my co-chair. I'm Job Snyders. Let's start with the first slide deck. Would you mind pulling that up, Chris?
Well, we had chair slides. You want to cover those first?
Please pay attention to the note well. The note well outlines expectations about behaviors and processes. But I think by now, at the end of the week, most of you have seen this slide multiple times. Next slide, please. Here's an overview of the resources related to the GROW working group. Our agenda is available online. Everybody submitted their slide deck for today's session, and you can find those online. We have a mailing list that is open for everybody to participate in. If you're interested in routing operations on a global scale, please consider subscribing to our mailing list. Next slide, please. The blue sheet no longer is a sheet, but a QR code. The QR code was at the entry point into this room. Make sure to scan the QR code and log in with the data tracker login. This helps us with planning the next session in terms of room size. Minutes taker. We need somebody to keep notes of what was said and processed in this proceeding. Is anybody willing to volunteer to be our minute taker today? Well, if nobody is volunteering, I'm going to try to give the job to somebody. Jeff, would you be so kind to be a minutes taker this session? Wow. Anyone else? Jared, March, you're volunteering? That is excellent news. We have a minute taker. The Jabberscribe's task is to keep an eye out on the chat room, and if questions emerge, we try to make sure that they are handled. Oh, it's Zulip these days. I'll keep an eye on Zulip. Agenda bashing. Can we skip to the next slide for the agenda? We're going to talk about documents in flight. Paulo is going to give an update on BMP, TLV, and EBIT progress. We have an update on BMP high availability data collection, an update about the BGP Yang model, and finally, BMP path marking. Is there anything that should be added to this agenda? Oh wait, I see that Martin Pels's item didn't make it into the slides. Our last item is Martin Pels on a mechanism to describe BGP communities in a JSON format. So I think with that, we'll need roughly an hour. Next slide, please. All right. Let's kick it off. Paulo, would you mind stepping forward to the stage and sharing with us your thoughts and insights on the BMP EBIT and TOVs.
Okay, this thing is equal to yes. All right.
You want me to do it, or you got it?
Thank you. Slides? No, no slides. Yes, slides. Can you hear me? Yes. So actually, I have three items to talk about. Two are the microphone. Yes. This? Wow. That close? Okay. Fantastic. Really close. So I have three items. It's the TLV, the EBIT, plus this brand new idea that all of you is going to love, not like love. Um, so next slide, please. We start with the TLV. Um, next slide already, because this is just a problem statement. You remember it from the past. It's just to make sure that there are TLVs in every BMP message. And we were missing that for route monitoring and for peer down. So what happened since version 7? We skyrocketed to version 10, first of all. And there have been a lot of minor fixes, but the two main things are first that so we are extending the route monitoring message with the TLVs, and I think in a protocol it's important to be consistent to something else that happens in the protocol. So until the previous revision of the draft, we were being consistent to peer up, peer down to let's say init and term messages. But actually, you know, that was a kind of a suboptimal. I think Jeff was the very first to notice that, you know, you have to parse the whole PDU in order to skip then to the TLVs, and the TLVs, they may convey some characteristic about the PDU. So it was like not so nice and beautiful. But let's say overall, we got through the revisions with, you know, comments like the one of Jeff, but saying, okay, it's not nice, but it's okay, right? I would say finally I did take this decision that, you know, we should be consistent to something. Let's be consistent to the route mirroring message, which is entirely TLV. So now we have a BGP message TLV, and the PDU is part of the BGP message TLV. So now you can do whatever you like. You can really put it, this BGP message TLV, you can put last, first, you can sandwich between other TLVs and things like that. I think it makes sense and it's much more beautiful than before. And based on Team Evans' feedback on the list, I did introduce the group TLV. Group TLV is because Team said like we can do essentially we can model one-to-one like TLVs to NLRIs. We can do one-to-one because there is the index 0, meaning it applies to everything, but then we can not do M-to-N, right, kind of relationship. So I said, you know, let's do the group TLV, and essentially we just, yeah, and I don't know, it can get complicated, but it is one of the way forward. Of course, on all of this, I very deeply appreciate your feedback if you have any. Next slide. Right, and what is the status? I would say that the status is simply that there is a little bit more feedback from Team Evans that I have to process. Actually, I am in waiting state. I'm waiting for some answers from him on the list. And I would say like, yeah, this is the status, and probably there will be more changes coming up in the next version of the draft. So this is it for the TLV draft. I don't know if there is any comments, if you want to make them now. Nothing. Share. Remote share. No. All right. Next slide. So this is about the EBIT Next slide. And next slide again, because I just recap the problem statement for the EBIT, but you already know from previous version. So what happened is that first the document was adopted by the working group. Thank you so much. And to be honest with you, I mean, there have been only really minor updates to the document. Nothing really worth mentioning. Maybe I removed a little bit of text and word because they were repeated from the TLV draft. And then I said, instead of repeating all of this, let's just refer to the other draft. I have still one open question. I don't know if anybody has any thoughts on it and whatever. Like the EBIT so far, we do apply it to informational TLVs and things like that. But of course, we have a stats message. We have a statistics message. And I was very much wondering, and that is in a TLV format. So I was wondering, would the EBIT apply to the stats message as well? If so, a little bit of text should be added, and I am really looking forward also on this aspect to feedback if there is any. I think it makes sense, but open to your thoughts. And with this, I'm finished on the EBIT as well. Any thoughts, comments? Cool. Next slide, please. Thank you. So this is like an idea that we have a little bit discussing with Camilo as well, which is logging of routing events in BMP, right? So what is the idea? Next slide, please. What? Okay. Chris, I never, sorry, Chris. So what is the basic idea here? The idea is that like we have a state synchronization with the route monitoring, meaning that it is mandatory that we have an initial flooding of data and then we get all the rest. We have debugging with the route mirroring. Okay, and with the route mirroring, we should send a verbatim copy, very high fidelity of what's going on. And then we have, session data and we have stats and all of that, right? But what we are really missing is a message type that is event driven, right? So I don't know, you have a policy, that policy is, I don't know, blocking or denying a prefix, then, we want, to be notified, let's say. Or for example, there is some sort of validation taking place on the router, I don't know, RPKI validation or some sort of other validation. We want to know that something didn't validate and things like that, right? So all of this so far, as I was saying, it doesn't exist. Also the on-change, on-change analysis. I mean, you have to do really differential analysis. For example, Adjre pre and post policy, you have really to go like and scan the whole pre-policy, all the post policy, and then you should derive what changed there, right? But you could also have, some sort of notification, like again, this specific prefix didn't make it to the post policy and things like that. So this is the intuition. It kind of makes sense to me. I hope it does for you guys as well. Super duper looking forward to your thoughts. Next slide, please. And so that was the intuition. This is the execution. So what essentially we did is we again did a message body that is consistent with the route mirroring. Again, so it's all TLV. We have a BGP message PDU and BGP message TLV that includes a PDU with the so-called event subjects. Event subjects would be an LRI, okay? And then the indexed informational TLV are the event attributes, right? And so far, the only TLV that I did define was the event reason, right? So why we are reporting something. So essentially now you can say that at the third NLRI of this BGP update message, that of course is an artifact, it doesn't exist. It didn't exist, it's just a way to convey the information that, for example, it was policy denied or it was not valid or something like that. Why I choose to go for a BGP PDU, right, to convey this information? Because I thought like we already have code to encode and to decode this kind of information. So I really wanted to be a little bit low touch. You know, it is an artifact. I could have invented something totally new and things like that, but it kind of didn't make sense to me, right? But again, super duper looking forward for feedback. Last thing, it's a tiny detail. In the flags, we have something that tells us whether it's pre or post policy, something. I just removed that flag because it's still following in intuition. The event happens between a pre and post policy, right? So it's in between, something is happening and it's generating this kind of event. Super duper, again, looking for feedback. Next slide, please. So status, I am super duper conscious that the draft need to be still worked upon. It's incomplete. Probably there are also some errors in it and things like that. It was really a work done in rush, but I wanted to make sure to present it here so to collect feedback in person other than the mailing list. Also, it's a very humble down proposal so far, like it only applies to v4, v6 IP prefixes. Can it apply to something else than just IP prefixes, right? And also, so far, I'm just saying that the BGP update is enclosed in the BGP message TLV, but can we maybe report on different BGP messages, right? So I am here, crucifix me, throw me tomatoes. I mean, I am looking for feedback. Thank you.
First up is Jeff. And after that, I am relaying a question from the audience.
Sure.
Yep. Jeff Haas, we shall not crucifix you because you would not be able to type so well. So you have reached a magic point of popularity, with a protocol when you know that you're trying to throw everything into it. So this is a good sign. The wisdom I would share with you is that when you reach that point, there's a lot of discussion about should you do this, and you're at the borderline right now of you now have interesting things you wish to report. You have a good mechanism that can carry it. You have some use cases that this may make sense for. You are heading down the road very quickly to a generalized streaming telemetry mechanism that other things may be trying to attach to. And you probably want to, as GROW, figure out what that line ends up being and try to keep the lines nice and crisp. Your overlapping spaces that you have to worry about are work out of like netconf for streaming Yang extensions. You have GNMI coming out of OpenConfig. So these are all good things. Specific to BMP, the thing I would suggest you is the same thing I give for the streaming telemetry feedback. This is critical data that you're trying to use. The more things you put into the drinking straw that's carrying the fire hose, the less you're able to carry through quickly. So you're starting to get to the point where you're looking for additional channels that carry the same type of information, same protocol, but perhaps don't overload it on the same session.
Okay, thank you.
Jared Macha Akamai. I want to echo some, in part what Jeff said, which is if we're going to have different BGP messages and stuff be reported, I mean, BMP is largely just the BGP on the wire in a wrapper. And so the ability to pass through the MP and, whatever other stuff is there. And then, back on the, kind of the specific monitoring piece, is the vision that the router that you would configure in the routers or the BGP speaker, the things that you would want it to highlight to the collector, or is that something that would happen in the collector? It sounds like that would be, in the router
Exactly.
that it would highlight it.
Yeah.
And then, that makes a lot of questions about, then you're sticking that in an ephemeral database on the router, or is it that live in the permanent configuration store, et cetera, et cetera.
Right.
Which you might want both. And then that gets back to the, is this analysis, should it just be done offline after the fact? And that's the way we've done it, is we're just taking all the data and we're processing that after the fact out of the routers. And just getting that basically the mirror copy of all the information. So, how much do you want to build the alerting mechanism into that and have that be integrated in the routers? And I think having the routers alert on that is a very dangerous and slippery slope.
Yeah, I see. To be honest with you, what I found out is that if you want to find a difference, like a pre-policy to post-policy, you have to mine a ton amount of data at the collector just because you are trying to find one tiny bit. But if the router is denying a prefix, for example, for some reason, let me put it in between quotes, the router already knows. So it just seems a more, I don't know, efficient process, although I see that then, you may be, let's say, you are overloading maybe the router. On another aspect that I wanted also to say, this is similar. The rel naming, it doesn't come out of nothing. It comes from NEL, the NetFlow event logging. So I was kind of thinking, we are building a super similar mechanism, but tailored to BGP, something like that. I don't know if.
I think next up is Ahmed El Hassani.
So this is more related, Ahmed El Hassani from Swisscom. So this is more related to the TLV draft. And I noticed that you bumped the version from 3 to 4 for all messages, which even for the messages that are not touched by the draft, the parser have to be updated and you have to do something different. I'm wondering why not just change the name a bit to indicate this is actually a new version that's coming up, and maybe bundle some of the other changes with it as well, since we are changing the version anyway.
Changing the name of the
draft.
Oh,
to make it more clear that there is a new version coming up.
Okay, thank you. Yeah, I will think about that. Yeah. You said you wanted to relay something from the.
Yeah, I wanted to relay a question from Jared Mauch, but then he walked to the microphone and asked the question himself. So, thank you so much, Paolo.
Yes, thank you.
Next up, BMP high availability data collection by Zuyang Lin. How do you pronounce your name? Would you mind sharing that?
It's Joya.
Thank you. Take it away, please.
Okay. My name is Joya Lin, and I'm a master's student studying in École Polytechnique in Paris. And I'm happy to introduce to you the high availability in BMP data collection, which is a project that I have done in Swisscom for the past 6 months from March. And next slide, please. The goal of this project is to guarantee and is to achieve BMP data high availability and also do possible load balance for other network telemetry data while not bringing a lot of data duplications. And nowadays, as the network going larger, it's more and more important to do network monitoring. So network telemetry is very important. And the network telemetry protocol we're using in this project is the BMP, which is based on BGP. And BMP can provide us access to different RIPs, as well as being kept updated about the BGP events happening in the network. And all this data is crucial for monitoring networks. The BMP works as following. It will have one BGP router in the BGP network to export BMP data to an external BMP stations. But as the network going larger, it might not be enough. It might not be enough to have only the single one BMP, one router and one stations architectures. So we want to introduce more collectors. And next slide, please. For prototype designs, we have used two collectors in the systems. Each collector will expose it. No, sorry. Each router will expose its BMP twice to the collectors. Means that both collector will maintain BMP's identical BMP sessions to guarantee BMP high availability. Also, with this architecture, it's possible to do load balance for other network telemetry data, for example, IPFix, but it's not further discussed here. And then, since we are having BMP data in both sites, if we dump both of them to the database, we might bring a lot of duplications. So at the end of dumping the BMP data in the collectors, we have designed a shared internal logic across the collector to guarantee that the BMP data is only forwarded once but cached twice. And next slide, please. The design is the following. We will make the collector to work in active standby states. And this active standby, while only the active collector will be dumping BMP data, and the standby collector will not dump, but still keeping the BMP sessions. The active standby feature is decided by its timestamp. The timestamp is set at the establishment of BMP sessions, and the timestamp will be sent to Redis as a key. And in this case, the collector can exchange it about their work state by the timestamp keys in Redis. And also signals are used for maintenance purpose, since we also want to manually configure the active standby states during runtime. Next slide, please. Since Redis is using key value form to store records, the timestamp keys sent to Redis is designed as the following to include all necessary information to identify the collector and the session. So we have included the cluster name and cluster IDs, and the cluster here includes all the collectors in the system. In the previous introductions, we have two collectors. So in the cluster, there will be two collectors. So the cluster name and cluster ID will be used to identify which one is it. And the core process name is used to identify which session it is, since we might have different network telemetry sessions. And these keys will be sent with a 2 seconds time up. So it needs to be kept refreshing, and if it's not refreshed, then it will be expired and deleted after 2 seconds. And then every seconds, the collector, the program PMACCT running in the collector will list all the timestamp it gets from Redis and set the dump flag accordingly. If the dump flag is true, then the collector will be active, and if it's false, then it will be standby. And there are the following 4 possible conditions. If in Redis there is only collector A's timestamp, then A will be active, and while the state of B will be unknown, because if for B Redis is unavailable, it will it will not be aware of the existence of other collectors. So it should be set to it should be set to active to make sure that the collector won't lose any data. And if in the Redis collector A has the smallest timestamp, then A should be active and B should be standby. And if A has not the smaller timestamp, then A should be standby and B should be active. Next slide, please. since we're using PMACCT in the collectors, it's easier for us to implement this shared internal logic. PMACCT is a powerful it's a powerful network monitoring tool. With PMACCT, we can simply implement the software logic at the dumping process and the dumping program of the BMP data. So it can so we can implement the logic easily. Next slide, please. There are two workflow for the projects. For regular workflow, we should first the system will write collector's timestamp key to Redis with a 2 seconds timeout, and then it will get all the timestamp from Redis so that it can be aware of the work states of other collectors in the cluster, and then it will make a comparison among all the timestamp and set the dump flag accordingly. More specifically, the 4 conditions that I have mentioned before, and at the end it will sleep for 1 second and repeat the whole workflow. And but if we want to manually configure the states, we can put it into maintenance mode by sending a signal 34, for example. Signal 34 is used to refresh the timestamp, and if this signal is called, it will set the collector will set the timestamp to current times, and write this new timestamp to Redis. Since it has now a larger timestamp, it will definitely become standby immediately. But for the other collectors, they will be aware of the change of this change by getting timestamps from Redis. So there might be some delays, and this delay will be maximum 2 seconds. Next slide, please. We have mentioned before that only the active collector will dump, but the standby collector will not export any metrics to the database, but it will keep receiving BMP data and BMP RIPs, BMP events in the local cache for 2 seconds. This is to avoid that if a failover happens. For example, if it needs to switch from standby to active, since there is a delay there, we do not want to lose any data. So the new received BMP events will be cached in the local buffer for 2 seconds. And once there is a failover happens, the data in the buffer will be dumped firstly. And the failover mechanisms work as following. Assume that there are 2 collectors, A and B, while A is active and B is standby. If collector A has crashed, for example, it has been shut down, then the key in the Redis will be timed out in maximum 2 seconds. Because we don't know that if it's being shut down by sending signals or shutting down the collector. If we shut down the collector, then we need to wait until the key expired itself, and only after the key in Redis expired, then the other collector can be aware of the change of this collector. And let's say B is now the collector who has the lowest timestamp, so it will naturally become active. And then what it will do is to firstly send the local cache to the database, and then it will work in the normal workflow to send all the BMP traffic that it have received to the database. Next slide, please. For testing, we have designed 2 daemon setup and 3 daemon setup. The 3 daemon setup is used to prove that this project can also be applied for multiple collectors. Next slide, please. We don't have animation here, so we can see that there are 2 pictures, and the first one is the results of 2 daemon setup, and the second one is 3 daemon setup. For the 2 daemon setup, if we look at the first picture of BMP metrics, we can notice that even though there are 2 collectors maintaining BMP sessions, there will be only 1 collector dumping to the database. So there is only 1 line at the same time. But on the right side, there are 2 pictures of IPFix loads received from the two daemons. So IPFix is always received and from both sides, and it will not be influenced. But since here we try to simulate the failover by shutting down the collector, the IPFix flow received from these 2 sides will be slightly different. So IPFix received from A will be slightly less than that from B, since we have shut down A to make the active failover to B. And for the 3 daemon setup, we can also notice that there is only one among 3 daemons. There is only one daemon dumping the BMP data, but however, IP flow is always received from all three collectors. So it works for both 2 and 3 daemons, even for more. And if we want to add more daemons, it's just a matter of configuration, and it's easily to add. Next slide, please. To sum up, the goal of this project is to the most important goal is to ensure the high availability of BMP data. And in the other hand, we also want to do a possible load balance by introducing more collectors to the systems for other network telemetric data. However, we don't want to introduce data duplications, since we have more collectors maintaining identical BMP data. So we have designed assistants to make sure that the BMP data is cached twice in the collector, but only forwarded once to the database to help in scalability. And that's all for the introduction. Thanks. And for backup, if we go to next 2 slides, there will be the state machine of the dumping process and the data queue. And that's all for my introduction. Thank you so much.
Thank you so much for sharing these insights and outline of the design to establish high availability in data collection. I think we have 2 people that want to ask questions. Let's go with Chris Morrow first, as he was the first one to indicate on Zulip that he has a question.
I think actually Jeff has the same question, so it'll be easier with him in the room, I think.
Okay, we go to Jeff.
This is Jeff Haas. Thank you, Joel, for your presentation. I had first one question about your timestamps, and then a comment about your methodology. What timestamp exactly are you collecting? What is the trigger event? Is this coming from the BMP protocol, or is this messages that are coming from the collector receiving a thing?
No, it's just the current time. It's the Unix timestamp.
The Unix timestamp of the collector receiving a message?
No, the Unix timestamp of the start time of the collector.
Okay. So this goes into my comment about methodology, I think. So one of the problems that you'll have for BMP is that with your displayed slide here, collector A and collector B, receiving from the same router, there's no guarantee that they will receive the same messages. In some cases, BGP suppression of route change may cause different messages to show. Route orders may be different, and other such things. So one of your challenges is for deduplication, that there may be different reasons why the collectors are not in the same point of synchronization with a router learning its state from BGP. If the routers go quiet and the state converges at the collector, the final state should be the same, but there's no guarantee that during learning state, especially during high degrees of churn, that the state will be identical. Have you accounted for this?
Since the BMP session is established from 1 PM from one BGP router, it's just about configuration. So we have configured the router to send identical BMP session to the collector.
I understand your configuration. What I am telling you is that in such a configuration, there is no guarantee that data is the same. The eventual converged state will be the same. So to give an easy example, presume that collector A receives prefix 10/8, from pure A, and much time goes by, and collector B eventually could receive the same state, or maybe 10/8 has changed at some point as well, and collector B is instead getting the most recent thing, while collector A has yet to receive the recent update. So eventual consistency shall happen, but incremental consistency is not there. This is a common problem with distributed computing type things. So my suggestion to you is, as part of your continuing work, maybe consider how you would want to address this in the database.
Yes, we have discussed this at the beginning, but since this is just for prototype, we have skipped this. We have considered to also sync the BMP data that you have received from the routers to Redis, so that we can make sure that they are working synchronously. But since this is just the first day, we have skipped this, and we by default consider that they are receiving identical BMP data. And in this way, if we ignore this, we can just implement the active standby feature. But you're right, this will be the next step to do, that we need to sync the BMP data that it receives.
Okay, thank you.
Any other questions, comments, remarks? Chris,
There's
you're
two.
in queue.
Yeah. So first off, I also would say this looks like pretty cool work. I appreciate you presenting it. And it wasn't clear from the slide deck that you're sort of in still the discovery phase of how this all works, or how it's going to work, I should say. I think the point Jeff was making, I also had the same question about what's sort of the primary key that you decide you got the same message at both places. It's not, it seems like that's hidden in your Redis custom key comment. So I think if you skip down the road later, you'll come to the same state where you say, oh, well, the BMP collection isn't necessarily guaranteed to be synchronized in time. That's sort of Jeff's comment, and that you'll have to figure out which NLRI, which BGP message in BMP is the same to tell which collector has you want to use here. And it may be that you don't even care so much about primary and backup state. You just care about getting a single stream out the back end. So anyway, I appreciate your presentation. It was super nice. Thanks.
Thank
you. Yeah, this is Seren Delsberger from Ost University. I have like a question about, you talked a lot about Redis. So have you also thought about like introducing an intermediate service to not only save the timestamps into a Redis KV, but also like another technology like memcached or something like that?
Could you repeat the memcached? Because I never heard about that before.
Yeah, I think it can be like, makes a lot of sense if you have like this intermediate service to just use also another technology, not only Redis. I mean, of course, Redis may be the major one, but maybe another company that does not use Redis. So you would have like a lot of advantages when you introduce like this intermediate service. Yeah, thanks.
The reason why I'm using Redis is that the Swisscom is already using PMACCT to do network telemetry in the collector, and Redis is naturally supported in PMACCT. And if I export the timestamp to Redis, since PMACCT is already used across the collector, then it's easy for them to exchange. But so I would say this design is highly based on the PMACCT, which is already used in the collectors. Then, but if we want to play for other company, then we need to who is not using BME CCT, then we'll need to decide another solution, probably.
All right. Okay. Makes sense. Thanks.
Thank you.
Severin, would you mind emailing the presenter a pointer to Memcached? Because I heard.
Absolutely. I will have an offline talk with them.
Thank you.
Thanks.
All right. Thank you so much for your presentation.
Thank you so much.
Move on to the next item. Camilo Cardona.
I always get nervous here.
Really?
Yes.
No need to be nervous. We're all friends here.
My first time was awful, so okay. So a couple of updates for a couple of drafts we have currently running on the working group. First of all is the update on the BMP and module. Next one, please. So this is a short one. So compared to the latest version we presented in the latest IETF, we had a few differences. So first of all, Tom Page went fully and doctor to the model. I can only thank him enough. He made multiple comments. We tried to address them all. We have still yet to change the names of some containers and identities. We have that pending. We'll do it. Jeff Haas, of course, always checks the model and he's very helpful. I also, again, can only thank him for his observations. For the more immediate stuff, since the first email, so since the first time we introduced the model, Tim Evans mentioned that he would like to have initial delay and backoff timers. That doesn't hurt. So initial delay, we added. Backoff timer is actually part of the BMP RFC. So we try to model that in the YAN module. If anybody can take a look. I personally check if there was any exponential backoff this container somewhere in the IETF. I couldn't find it, so I mean, we did it from scratch. That's it. For the more controversial part, yeah, Jimin Shen, I think I mentioned this briefly, the latest IETF. He mentioned an use case in which he would like to send specific prefixes to the station, to the BMP station. This goes very well with our thought or what we have presented previously, in which we would like to have a very flexible but very accurate way of defining what to send to the station, because not all of us have ways of ingesting 50 million packets every minute. And so having a way of selecting exactly what you want could help extend adaptability, adoption of BMP. So Jimin actually also mentioned that there was this routing policy model already available in the IETF, already standardized. So we're using that. The routing policy model, even though simple, is still powerful enough that maybe there can be some stuff that makes no sense for BMP, like if you mash or filters on like an attribute, maybe that makes no sense, but we'll see. I mean, we'll check it out how it works, but we added it. Yep. Next one, please. That's it. The call for adoption, I don't know if it got a bit orphan shares. I don't know what happened there, but we'll continue working on it on this because I think we need it.
I will double check the status and do the needful thing. Thank you for the reminder.
Okay, that's it. Any questions or comments? Let me see, there's none.
Do you want your path marking one now? Camilo?
Oh, what?
You want your path marking deck now?
Yeah, let's do the next slide deck. No questions.
Yeah.
Path marking, you're up again.
Okay, so for the next one, this is another draft that we introduced previously, even a couple of years ago. Just an update on this one. Next one, please. So this is the path status TLB. So just as an overview, what this TLB does is to convey the path status of a path. In a TLB option, what is the path status, whether the path is installed, whether the path is a backup, whether the path has been rejected or filtered, whether the path is a NAT path, whether the path is used for forwarding, like this sort of thing. And there's an optional reason field if you want to go crazy, and convey also why the status happened, like if it's filtered because of local preference, oh, sorry, if it's installed because of local preference, or I mean, if you can do that, then there's an optional result field for that. It depends on the TLB draft. Paolo already, I mean, that's getting progress, so it's getting mature. So we were more confident about this, also about with the EBIT. I don't know if you follow the EBIT, when Paolo just introduced it. So thanks to the EBIT, basically every company could do their own status, right? So, I mean, if they have a proprietary way of a status, then they can use the EBIT and convey it. Next one, please. So there's no much difference on this draft compared to the latest version. Some small editorial changes. We added a few more examples on path status. So here's the thing, in the draft, we actually don't want to standardize any path status. We want that to be done somewhere else. I think I always get lost. I don't know if it's in YANA or I get lost where this sort of thing gets standardized. But still, I really, well, this is me. I really think that without the examples, it's very hard to understand the draft. So, but maybe with this, it's a bit more clear. So I do not know whether I mean, just to make an next version without the examples of path status and just continue doing it like that, or keep it there for a while, so to make it clear for the people that read it, or I don't know, reference a previous version, which I don't know if you can do that. So that's a general question. I do not know how to do that. So, or at least maybe we can discuss it later. Next one, please. Okay, so again, why this is interesting in our first use case, it will be, for instance, interesting to know when a path is being filtered. Right now, yes, we can do that. We can take the pre-in, the post-in, compare it. It's a lot of work. And this is interesting information if you can obtain it directly from the router. And if you can know the reason or the status, like if maybe a path was filtered because of a policy, maybe a path was filtered because it has an invalid draft. I mean, this sort of thing can be useful because if we have data, other data, additional data from the network or historical data, then we can know if maybe something is wrong before somebody calls and complains. I mean, that's like a low-hanging fruit. Again, we can do that already, but comparing pre and post in can be very painful if you have a lot of messages or a big routing table. In a more complex cases, but it's still useful. At least Paolo and I, both co-authors of the draft, at some point in our careers, were working in a system that that basically would like to offer what-if scenarios for networks. And of course, nobody wants to do a BGP simulator for that. But if the router somehow can send what paths are backup, then you can, let's say, cheaply do some what-if scenario analysis like, okay, if this fails, then I already know the backup. It might not be perfect, but it's better than nothing. So that's, for instance, one other example. And also, if you have a very diverse environment with a lot of paths, then you're getting from the local RIP, for instance, then you might be able to know which paths are being used for forwarding or not. I mean, you can have different use cases for that. Okay, next one, please. The status of this, from what I understand, but I need to officialize, Huawei already supports it. We have, I mean, I modeled this in SCAPI and against PMHCT, and it's already showing it. So at least there's word there that the wire format looks good enough. So there's a bit of implementations. I mean, we probably need to officialize that so to move this forward. But if anybody has any more questions or comments, please let us know, or I mean, ask here. And that's it.
Thank you so much. Any questions, comments? All right. Thank you, Camilo.
Thank you.
I would say this was a smooth presentation. Thank you for your time. Next up, we have Martin Pels for a topic that is not yet an internet draft, but perhaps beautiful things will come out of this. Take it away. Oh, and make sure to point the microphone at your mouth.
Is this okay?
No, maybe just hold it.
Oh, here we go. So yeah, as Job mentioned, this is not a draft yet. Could be, maybe. I just wanted to throw this at the group to see if there's interest for it. Next slide. So the basic
Mark.
idea is...
You're gonna have to get closer to the mic. You're just barely audible. Yeah. You have to actually speak directly into the front of the mic. So hold it in your hand and you're, yeah, great. Pretend you're 50 Cent.
Okay. So yeah, it's not a draft. It's just an idea I wanted to throw at the group. And the idea is to define BGP communities, large communities, extended communities in a JSON structure. Why would you want to do that? First of all, to have a standardized way for publication. Right now, ISPs publish their BGP communities on their website or in their Autumn objects in the IRR, but it's all plain text, and if you want to do anything with it, you're going to have to figure out what they actually want and how to parse that. So yeah, that's the second reason for wanting to do this is if you have tools that want to look at BGP communities, such as looking glasses, then it becomes much easier if we have a structured way to describe them. Next slide, please. So an example tool that could use this is a looking glass. So I'm part of the NLNOC, and here we run a looking glass that we recently modified to display descriptions for BGP communities. And this is basically a self-compiled text file with communities and descriptions. And yeah, if you want to change anything to that, you have to go in and modify a text file, yeah, which is not really a nice solution. Next slide, please. So I made some examples of what this could look like. First example is based on the RFC 8195. This describes a way to use BGP large communities and sets up a structure with ASN, a function, and a parameter. So it divides the community up into 3 fields. And then the RFC also gives a couple of advantages, examples, such as defining community for to instruct an ISP not to export a route to a certain AS. Next slide, please. So how would that look in JSON? What could it look like? We would have a template for the community. In this case, I'm calling it RFC 8195. And there we define the 2 custom fields that this community has, function field and the parameter field. Next slide, please. And then based on this, we would have a large BGP community, in this case, instructing AS64497 not to export to AS6551. And there we indeed again take the 2 fields, the function field, we set it to 4, which in the previous slide was set to no export. And as a parameter, we take the AS of the peer that we do not want to export to. And of course, we also have the global administrator field that we filled, so that's the ASN. Next slide, please. Another example is for an RFC 4384. This defines BGP communities used for data collection, and that can be used to tag your prefixes with for example, a region or a country code to show where they were originated. Next slide, please. So here we do a similar thing. We have fields for the region. This RFC also has a satellite field, which is 1 or 0, and a country code, which is encoded in a bit string. Next slide, please. And again, then we would have an instance of this community, which would define routes originated in the Netherlands, which would have a particular region, EU. This is the bit string defined by this RFC for EU. Satellite set to 0, and the country code for the Netherlands encoded according to this RFC. Next slide, please. So yeah, this is all just a rough idea. I would like to hear some comments if this is interesting, and if there are people that would like to work on this, please come talk to me.
All right, Jared was first in the queue, so let's start there.
Jared Mach, Akamai. So I think this could be interesting. I think there's a couple concerns I have, which mostly can be solved. So for example, that there is the IANA registry, for example, that has all of the well-known BGP communities in there. And so I don't know if we would want to look to that for some of the formatting and stuff, because they do already have an XML format. I know JSON is the current sexy thing until we all move to CBOR or something else, you know, or whatever is in the future. But we may want to just look to that for some of this, because there is a lot of ranging here. The other thing is, having been involved in a different discussion earlier today about or this week about regular expressions and how to define those, a lot of us have BGP communities that match regular expressions that we would maybe not want to specify all of the things, but be able to drop a regex in rather than expanding the entire thing, because it's going to be very large. So we need to think about how we would encode either regexes or ranges, some of which is done there. I think the other thing is we want to also be a little cautious about this, because there have been efforts in the past to try and define a number of new softly well-known BGP communities, like same country or country codes and stuff like that, and trying to standardize that across the industry as well. And so we should be conscious as we're doing this. And then the last piece is the same as many other things like geofeeds and such, is how do we discover where defined the list of them. So if I as Akamai or I as, you know, use ColoClue, you know, have a list of those, you know, how do you discover where their well-defined and well-documented list is? Is that something we want to have in scope? So that's a couple of my thoughts on this. I don't know if you have any feedback on that.
Thanks, that's very good feedback. On the last one, Job actually suggested maybe we could do something with the RPKI to publish them there. But good feedback, and thanks.
Hey, Camilo Cardona from NTT. I would just say, I mean, this is not anything against. I'm just saying, consider also doing it in YANK or doing it in YANK and making a JSON schema from it. I mean, I'm not going to say no to a JSON schema. It's also fine. I'm just saying that maybe for the machinery of the IETF, you will find at some point somebody that says, why not YANK? Well, maybe the structure is simple enough. I think there will be no problem doing it there. That's it. I mean, just consider doing it in YANK. And I think you can convert it to JSON schema easily from there. That's it.
Okay.
Jafaz, I've been having a flavor of this discussion 3 or 4 times with different people, including with Job and Jared and a few other people. So the thinking is in the right ballpark. So this is a good idea. I think I would suggest taking a number of different directions. But what I'll suggest directly is I'm happy to directly collaborate on this one because I have a large wish list and suggestions on how this can move forward if you're interested. But the easy ones are Yang schema to model the thing, and then at that point you have many places that you can transfer the data, including CBOR. The thing you're going to find is high-level problems. Jared hits the point of we don't want to try to be too normative about how people use communities. Mostly what we're looking for is a way to allow for communities to be described and allow that to be consumed by routers for informational purposes or config purposes. That moves us into the problem of how you distribute the thing. RPKI is an example of how you would want to maybe discover these sort of things, or at least where to pull the data from. Signing the data from the provider falls into the same place. And finally, the speed at which you can consume these things. JSON is not it's not the worst format ever, but it's pretty darn close. And you're going to find, yeah, it could be XDR or something like that. But being able to consume the things fast on the routers would probably push us to something more along lines like CBOR. We're starting to get good experience across multiple vendors with that is a nice binary format for fast consumption of structured data. So a lot of comments, good idea. Thrilled to collaborate if you want that.
Much appreciated. Thanks.
So, Ahmed Al-Hassani from Swisscom. Very interesting for sure. Just a few things I would like to point here. I'm not sure if you think about it before or not, but right now we have collectors like BMCT, which is collecting LibBGP traffic and then push it back to for further analysis in some kind of message bus. And they look at the BGP messages and then transform it in non-standard way to another format, JSON or Avro or something like that. And would be nice to look at this use case in general. It's very interesting use case because most of the analytical programs on top of these things will not consume the wire BGP. It's not only about the community, but maybe we should start to consider like what other type of applications in the network automation mode that will need to understand the BGP messages as they come from the router, but they don't want to deal with parsing BGP messages because that it's kind of complicated and you don't want to have it everywhere. Just FYI.
Okay, thanks.
Rudiger Volk is remote. Rudiger, can you say something?
Okay, maybe. Okay, I think I'm being heard now. Kind of interesting stuff. When I got around to work on the large communities for my policy definition and configuration generator system, I invented something and got it implemented that I called community registry. Actually, I think almost all points that Jared was mentioning were covered. Actually, there is even a documentation in our internet draft form, but I have been told the complexity of the whole system and the specific application is really confusing, so that internet draft form cannot be really used to share. The main characteristics of the community registry are the presentation. Instead of doing JSON, looks a little bit like, say, domain name notation or similar stuff, where you can put in symbols and parameters into a structured string, and you have an XML definition of how the community fields are defined, and you can even generate the regular expressions used in vendor policy languages for matching simple communities or sets of communities or communities with some of the used parameters wildcarded. And as far as I can tell, I think that is still working. And about the only major thing that has been mentioned in the discussion right now that I think has been missing in our work was that, yes, we did not address how to make a system for global access to definitions, though in fact kind of that would probably fairly easily fit into the XML that IENA is using for its registry. I'll try to pull out some easy stuff from the old documentation and share that, and people who are interested probably should bother me in private email. Yeah, well, okay, just as a report so far. Though no JSON would happen or did happen in that was XML based, yeah, well, okay, so much to tell. Thanks.
All right, thank you. We'd definitely be interested to look at that, to see if we can learn from it and not reinvent the wheel or make mistakes that maybe were made there. Thanks.
Sorry, it's Chris Morrow, Google. I have a question. Have you looked at, I mean, the communities JSON thing is interesting. I think Ahmed's point about perhaps the larger BGP message as some standardized form other than binary BGP data would be useful as well. We ingested all of the route views data and put it into BigQuery, and in that process converted it to JSON kind of on our own. I don't know that we picked a particularly terrific format for that, but if there was a standard format, we could just go redo it to make it useful. Our point, or our project, was really to make the data available to researchers in a fashion that didn't involve them having to download it all, parse it into something, and then do something else with it. So some more general conversion would be helpful, I think. Also, if it was standardized, it would be helpful.
Okay.
Thanks for the presentation too.
Jeff?
Jeff As, hey Chris, just as a follow-up to your point, I don't think it's quite in the scope for what we're looking at specifically for this presentation. So what you're sort of talking about is it'd be sort of nice for things like, like the prior presentation, Redis, Kafka, pick whatever your bus happens to be for throwing BGP state at something that needs to catch it, of having consistent naming for the fields. It would make, like even MRT parsing programs a little bit nicer, that sort of thing, so that all the schemas can be folded together. This is sort of an interesting related piece there, which is once you have parsed out components like communities or AS numbers or whatever, having a consistent mapping component where something says, here's what this means. AS numbers, you can point to like the whois data of what they claim their network means. And I'm sure you probably fold that stuff at the back end yourselves. So this is the same sort of thing of, what would you do with a operator defined thing like a community, extended community, especially for like VPN context. Some of the best stuff that we're seeing, in terms of user-defined data, having a more generic format to try to unfold that into a user printable component. I think if that's your goal as well, and this impacts the discussion here, is part of the challenge will be internationalization components to this. So if you say, here's a definition file for communities, part of the requirements discussions I've had with other people in other contexts is how do you provide multiplicity for some of the fields like a description. So here's the English version of this string. Maybe you want this also in a native language, for the operator as well. Thanks.
Jared, do you want to take a mic?
So it seems there's a good amount of interest to explore this space, and everybody has opinions on almost every aspect of this proposal, which to me means this is a good candidate to take on as work with the goal of making it a working group document. Sorry? Exactly, that small detail. I'll make the logo, you guys do the internet draft. No, but really, Martin, I would encourage you to write an internet draft and submit it to the working group for consideration. And I think the time is ripe to try to standardize mapping community values to human readable text. Cool, thank you.
Thank you.
And with that, we have almost reached the end of our Grow session. I noticed that I forgot a small agenda item. I was going to go over drafts that are in flight, but then I didn't actually go over those. We have one ongoing call for working group adoption related to the BGP well-known community for Anycast. A few people already responded on the mailing list. The call will be open for another week or so from the top of my head. So please take a look at that internet draft and reflect on the mailing list whether you support adoption, wish to contribute to it, or not. And that's it. Thank you so much. The next Grow session is going to be at IETF115 in Yokohama in Japan, and I look forward to seeing all of you there. Have a good day.